Title: Elevator Encoder vs Resolver, what's the difference? Hook. When people compare elevator encoders and resolvers, the first question is usually, which one is better? But in elevator engineering, that is not the best question. A better question is, which feedback system fits the elevator control architecture, operating environment, and long-term maintenance plan? Both encoders and resolvers provide motion feedback, both help the controller understand motor speed, rotation direction, shaft position, and real-time traction movement. But they generate and process feedback in very different ways. That difference can affect VVF integration, PM motor synchronization, ride comfort, commissioning complexity, modernization flexibility, and long-term reliability. Why feedback matters in elevators. Modern elevators rely on closed-loop traction control. The controller does not simply command the motor to move and assume the elevator is following correctly. Instead, it continuously compares commanded movement with actual motor behavior. This feedback helps regulate acceleration, deceleration, low speed travel, floor leveling, and ride comfort. When feedback is unstable, the elevator may show problems such as repeated releveling, low speed vibration, jerky acceleration, unstable deceleration, delayed stopping response, or unexpected shutdowns caused by signal faults. So choosing between an encoder and a resolver is not just a small component decision. It is a feedback architecture decision. What an elevator encoder does? An elevator encoder is usually mounted on the traction motor shaft. As the shaft rotates, the encoder generates digital pulse signals. These signals allow the controller to calculate elevator speed, travel distance, car position, deceleration timing, and leveling correction behavior. Because encoder output is already digital, modern VVF inverters and elevator controllers can process the feedback directly. This makes encoder-based systems easier to integrate with digital control architecture. Encoders are commonly used in modern passenger elevators, machine room, less elevators, high-rise elevators, and permanent magnet motor systems. They are strongly associated with high positioning precision, smooth low-speed operation, stable acceleration curves, precise leveling, and improved passenger ride quality. For most modern passenger transportation systems, encoder feedback is usually preferred because it fits naturally with VVVF control, PM traction machines, and digital monitoring systems. What an elevator resolver does? A resolver works differently. Instead of generating digital pulse signals, it works more like a rotary transformer. It produces analog sine and cosine signals, according to shaft position, before the elevator controller can use this information. The signals usually need to pass through resolver to digital conversion hardware. This means resolver-based systems may involve more calibration, more conversion hardware, and more tuning complexity inside digital control systems. But resolvers have one major advantage: durability. Resolvers can tolerate vibration, oil contamination, dust exposure, and temperature fluctuation better than many encoder setups. That is why resolvers are still valuable in harsh operating environments. They may be used in industrial freight elevators, heavy-duty lifting systems, outdoor lifting equipment, high-contamination shafts, and industrial mobility applications. So a resolver is not simply outdated. It is often chosen when environmental durability matters more than high-resolution digital refinement. Encoder vs resolver. The key difference, the simplest difference, is this: an encoder provides digital feedback. A resolver provides analog feedback that usually needs conversion before the controller can use it. But the practical difference is bigger than signal type. Encoder systems usually offer easier integration with modern VVF control, better digital compatibility, higher positioning precision, and smoother low-speed refinement. Resolver systems usually offer stronger environmental resistance and long-term stability in difficult operating conditions. So the real trade-off is not just precision versus durability. It is about how the feedback system fits the elevator's complete control strategy. Why PM motor elevators usually prefer encoders? Modern passenger elevators often use permanent magnet synchronous motors. These motors are efficient, compact, and suitable for machine room-less elevator systems, but they require accurate rotor position synchronization. The inverter needs to know rotor position clearly so it can control torque properly. Encoder feedback helps the inverter coordinate motor output with rotor position in real time. This improves low-speed smoothness, deceleration stability, leveling precision, energy efficiency, and passenger ride comfort. In modern traction systems, even small feedback instability can affect operation near floor zones. An elevator may run normally at full speed but show vibration or repeated leveling during final deceleration. In many commissioning cases, the issue is eventually traced back to feedback instability rather than traction machine failure itself. When resolvers still make sense, resolvers are still useful in elevator applications where the environment is difficult. For example, if the elevator operates in a place with severe vibration, dust oil contamination, large temperature changes, or long industrial duty cycles, resolver durability may become more important than advanced positioning refinement. In these projects, stable operation over long service periods may matter more than ultra-high feedback resolution. Resolvers can also remain practical in legacy systems that were originally designed around resolver-based feedback. Replacing the resolver architecture may not always be simple, especially if the drive, controller, wiring, and conversion hardware are all designed around that system. Modernization and retrofit challenges. Modernization is where the difference between encoder and resolver systems often becomes very practical. Older elevators may use resolver-based legacy drives, outdated signal conversion hardware, incompatible controller protocols, or wiring that does not easily support a new feedback architecture. If a modernization team upgrades to a PM motor or a modern digital controller without reviewing the existing feedback system, the project may face longer commissioning time, tuning problems, signal mismatch, higher retrofit cost, increased downtime, and more difficult maintenance. That is why feedback architecture should be evaluated early in modernization planning. It should not be checked only after the traction machine or controller has already been selected. Conclusion. So what is the difference between an elevator encoder and a resolver? Both provide motion feedback, but an encoder provides digital feedback that integrates more naturally with modern VVVF systems, PM motors, digital controllers, and high-precision passenger elevator applications. A resolver provides analog feedback and usually requires conversion hardware, but it offers strong durability in harsh environments with vibration, contamination, and temperature fluctuation. The better choice depends on the project. For modern passenger elevators, encoders are usually preferred. For harsh industrial environments or some legacy systems, resolvers may still make more sense. The key is not choosing the better component in isolation. The key is choosing the feedback architecture that matches the elevator system, operating environment, modernization plan, and long-term maintenance strategy. For more details, you can read the full article here. https://ficonalift.com. Elevator, encoder vs resolver phase.